We want to dance, dance, la 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 la, ooh. And I'll spin and dance and I'll even break it down. Wiki, wiki. Oh. Look at this new set. We finally made it big time. Ah, yes, I love it, don't you?
Divide, add or subtract, figure what the answer will be. You can do it with a little help from your friends here on TV. Math homework helpers, it's time. Math homework helpers, oh yeah. Math homework helpers, it's time. Math homework helpers, oh yeah.
Fourscore and 7 years ago today, our forefathers brought forth upon this continent a new nation, conceived in liberty and dedicated to the proposition that all puppets are created equal, and so on.
Adam, I'm glad to see you know your history. That could very well be the most important speech ever given by a U.S. president. Mr. Lincoln would be proud of you.
What? President? Lincoln? What?
And with President's Day coming up, it's an excellent choice to start the show.
What? This speech was given by my great-great-great-great-great-great-great-uncle shortly after the Puppet Rebellion of 1804. What are you talking about?
The Puppet Rebellion of 1804?
Yes, the Puppet Rebellion. I'm sure that you've heard of that. Everybody knows about the Puppet Rebellion.
Oh, yeah, the Puppet Rebellion of 1804.
Yes, exactly. Yeah. Trying times for the entire puppet nation of the 17th century, I tell you.
Well, you'll have to tell us all about that after the show.
What? That is an excellent idea. We could talk about that for hours and hours and hours. I love puppet history. Did you know?
I just remembered I have laundry to do after the show. I'll take a rain check on the puppet history lesson, Adam.
Yeah, I have laundry to do too. Sorry.
Enough of puppet history for now. Let's get to it. Welcome, everybody, to Math Homework Helpers. I'm Mrs. Studi from Riderwood Elementary School, and this is Miss Herring from Delaney High School, and this is Adam, Puppet Historian.
I am, and I have no laundry to do. Hello, kiddies! Welcome to Math Homework Helpers, and our prize wheel is ready to go, and you know what? We're going to have our talented studio camera people spin the wheel a little bit later on in the show. Sound good?
Sounds good for us.
All right, good.
We're here to help Baltimore County Public School students with their math homework. So if you need some help with your math homework, go ahead and give us a call.
What's the number?
The number is 410-494-1459. That's 410
Yes.
494-1459.
Then, after we work on your math homework, you get to spin the prize wheel. Okay, who's going to be the very first Math Homework Helpers caller on this fine Wednesday afternoon? Let's go to the phone.
Let's go to the phone. Do you know how many times I've said that phone number? If I had $1 for every time I said the phone number, I would be totally loaded.
That would be great.
All right, hey, you know what? Why don't we go to Millbrook Elementary School and talk to somebody about multiplication?
Sounds like a plan.
Tavon, are you there?
Yes.
So what's going on?
I need some help doing my multiplication set.
You know, you have come to the right place. How do you like my hat?
I'm not watching TV right now.
Oh, you're not watching TV? Okay, well, we can still work on your problem, and just picture this. A monkey with a very tall black stovepipe hat like Abraham Lincoln on his head. Can you imagine that?
Mm-hmm.
Okay, that's what you got. Now what's your problem, and we'll work on it together. And sitting next to me, if you can imagine this, are two beautiful 20-year-old mathematicians.
Oh, Adam, you're so kind.
Thank you. What's your problem, Tavon?
Okay, my problem is 12 times 24.
12 times 24.
I think we can handle that.
Sure we can. All right, what we're going to do, Tavon, is we're going to start with the ones column. We're going to do 4 times 2, which is? Do you know what 4 times 2 is?
Or 2 times 4.
Or 2 times 4 is 8. Then 4 times 1 is?
1 is 4.
4. Now what do we have to do to hold our place? Underneath the 8, we're going to add a 0
Yeah, what do they call
as our
that?
placeholder.
Annexing a 0? Or is that
Annexing
something
a
else?
0. Then 2 times 2 is?
2 times 2 is 4.
And 2 times 1 is?
2.
Okay, and then do you know what we do with those two numbers?
I do.
What do we do, Adam?
Add them up.
There we go. 8 plus 0, Tavon, is?
8.
Good. 4 plus 4? What's 4 plus 4?
8.
Nice. And then we just bring down the 2. And the answer is 288, 288.
And Tavon, do you know what the other name for the answer in multiplication is called?
No.
You?
I know what it is.
Lay it on us, Miss Studi.
It's the product.
The product.
And the 12 and the 24 are called factors.
Okay. So, you know what, Tavon, what we get to do is we spin our prize wheel for you now. And Kendra is going to spin it for you, and we're going to win you a prize. We'll tell you what it is.
Okay.
Come on, Kendra. Give it a spin. She's
Woohoo!
crossing her fingers for you. She's spinning the wheel, and the magic math kit is yours.
Okay.
Is that what this one is, Adam?
Yep, he won't be able to see
that's
it,
the
but
magic
there
math
it is.
kit.
Tavon, to let you know what's in the math kit, you've got a ruler and a compass and a protractor and a pencil sharpener and some other fun tools.
Okay.
Okay.
We'll send that out to you.
Okay, all right. You know what? Why don't we go out to Norwood Elementary School and talk to Jahat? Are you there? Jahat?
Hello?
Hey, how are you?
Hi, good.
What do you think of my hat?
I can't see it.
You can't see my hat either?
No.
Well, it is a fabulous black stovepipe hat, the kind Abraham Lincoln would wear.
Cool.
So I'm wearing this hat, and you can let us know what your problem is, and we'll figure it out.
736
736
plus 183
Plus 183,
plus 242.
242,
241.
241.
241.
All right, so 736 plus 183 plus 241.
Yep.
3 numbers. We're going to line them all up and add them up. All right,
what'd
you
you say
ready
you
to
call my
do
name?
some addition for me?
Okay.
What's 6 plus 3
9,
plus 1 more?
10.
10. And we're going to regroup with the 1. So 1 plus 3 is
4,
4 plus 8.
12,
And 12 plus 4.
16,
And we regroup with the 1. And 1 plus 7
8,
plus 1.
9,
And 9 plus 2,
11.
11. So I have an answer that says 1160. I'm going to put a comma between the 2 ones, and it's 1,160.
Hey, before we move on, can I ask you a question?
Yes,
Jahat?
Adam, of course you can.
Now, we know that the answer in a multiplication problem is called a product, right?
Correct.
But what is the answer in an addition problem called?
It starts with an S.
Super?
And ends with an M.
It's a sum, Adam.
Sum.
The sum.
That's right. Rhymes with thumb.
Correct.
But you want to call it a thumb.
No,
No,
thumb.
we call it a
It's sum.
Sum. Fantastic. What do you say that we spin the prize wheel for this spectacular math student?
All right, let's get a good
All right.
prize.
We got Kendra on the wheel again. There she, oh, she's got the lucky sombrero.
Woohoo! Sombrero. Cinco de Mayo.
Oh, it's a water bottle. Oh, with the hot weather coming up, you're going to need to be hydrated in order to do well in your math class. So we'll
It is
send it
hot.
right out.
It's already hot.
It is getting hot. It's like 60 degrees out
I
there
know,
today.
it's crazy.
All right, I'll tell you what. Why don't we go, let's see. Let's go to Kristen, who happens to be out there. Kristen, are you there?
Hello?
Is this
Yeah.
Kristen? Kristen, what school do you go to?
Bedford.
Bedford.
I love Bedford. How do you like my hat?
It's tall and black.
It is tall and black. It looks just like the one Abraham Lincoln wore, doesn't it?
Yep.
And it doesn't even fall off my head. I can turn my head fast, look up, look down. It's amazing.
Good job.
Okay, so what is your problem, Kristen? We can work on it together for the betterment of all children in Baltimore County.
72 divided by 8.
Yeah? We have a
Okay.
division problem.
72 divided by 8.
Wait, how do you know which one to put where?
Well, 72 is called the dividend,
Dividend.
and that goes inside the cave.
Oh, so the dividend is living in?
The dividend is living in the cave,
I got it.
and the divisor is outside.
Okay.
Now what you would like to do is figure out how many 8s you can take out of 72.
All right. So,
So
if
we
you know your
can-
multiplication tables, you might be able to figure out this.
Yeah, you can
pretty quickly,
count.
huh?
You can count by 8s if you want to. So we could start with 8,
8,
6,
16,
24.
24, 32,
Good.
Keep on going, Kristen.
40,
Whoops.
48,
Okay, that's 8 times 6.
56,
Nice.
63,
Close. Yes, let's see. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64.
60,
And then we want to do 8 times 9 is,
72,
there you go.
Oh, look at that.
Let's count how many numbers are in the skip counting that we just did. So there's 1, 2,
1,
2,
2,
3, 3,
3,
4,
4,
5,
5,
6,
6,
7, 8,
7,
9.
8,
So
9.
there you go.
So you're saying that 8 will go into 72 9 times?
Yes, it will, evenly.
It
And
does
9
go
is the, do you know what it's called, Adam?
Oh, I was just going to ask Kristen that. Okay, Kristen, question for you. All right, we know the answer in a multiplication problem is called a sum. We know the answer.
Nope. Multiplication
Oh,
problem.
sorry, product. The sum is for an addition problem. Thanks
Right.
for
Yes.
correcting me. Now, what is the answer called in a division problem? Kristen, do you know?
No.
It starts with a Q, I think, right?
Yep,
That's correct.
it's correct.
Miss Herring?
It's called a quotient, Adam.
A quotient. I knew it started with a Q.
quotient?
Yeah.
Uh-huh.
Quotient.
The answer in a
Quotient.
division problem is called a quotient. So,
You learned something new today.
let's spin the wheel for Kristen. What do you say?
Sounds like a plan.
All right, Kristen, hold on. We're going to spin you a prize. And Saranya is going to do the spinning. Let's see if she has a more powerful spin than Kendra. Oh, she's got thumbs up. Let's go. Come on, give me a prize. Look at that spin. Oh, it's a backpack.
Nice. Is
We
that a
will-
new?
Yeah, it's pretty new. It's those blue backpacks.
Oh,
thought
I know it. I've seen it. I
We've
know what
seen
it
it.
I don't know
is.
what I
Facts.
did with it. I had one over here somewhere.
It's got
I
like
must have-
black straps that you can hang on.
Yeah,
your
it's
back.
little straps.
Oh, I know. I've
We'll
seen
send that out to Kristen very shortly. Okay. Now, without further ado, let's go to Scott's Bridge. Are you there, Dommy?
Yeah, I'm here.
How you doing, Dommy?
Good.
Nobody really calls you Bommy, do they?
Well, they call me Tommy.
Right, I figured they called you Dommy. I was just wondering. Teleprompter operators, you know, you can't live with them, you can't live without them.
What's your problem today, Dommy?
It is all about the greatest common factor.
Ooh, the least common factor. Isn't there an acronym for
The
that?
greatest common factor or the least common multiple?
Oh, yeah, there was something like
The
that.
greatest common factor.
The
is that called?
GCF.
Oh, the GCF!
Okay, go ahead. What are the numbers?
Which is the GCF of 24 and 64?
24 and 64. All right, here's what we're going to do. We're going to list out the factors of 24. Okay? And what we're going to do is I'm actually going to, we're going to try to prime factorize this number so we can get the greatest common factor. So give me two numbers that you know can be multiplied together to get 24.
24 times 1.
Okay, how about two others? Since it ends with an even number, what number do we know is divisible into 24?
2 times 12.
Beautiful. 2 times 12. But you know what? 12 can be broken down a little bit further also. So give me two numbers that multiply together to give you 12.
3 and 4.
Okay. 3 and 4. And 3 is a prime number and 2 is a prime number. How about 4? What two numbers multiplied together give you 4?
2 and 2.
2 times 2. So my factorization for the number 24, I've got 2 I've got 3 2s and a 3. Okay? Now we're going to do the same thing with 64. 2 numbers multiplied together that give you 64 are what?
1 times 64.
Okay, 2 others besides 1 and 64. Okay, again, it ends in a 4, so what number can go into it? It ends in an even number, so we can divide evenly by...
I think she said 2.
Did you say 2?
I think so.
Okay, so 2. So 2 goes into 64, and that's maybe one we have to do on the side. 64 divided by 2. 2 goes into 6 3 times. And then 2 goes into 4 2 times. So 2 goes into 64 32 times. I'm going to do the same thing over again, and this time I'm going to say 2 goes into 32. Do you know how many times 2 goes into 32? If we do on the side 32 divided by 2, 2 goes into 3.
0, 2 goes into 3 once.
Once. And so that's 2. What's 3 minus 2?
1.
And then we bring down the 12. And how many times does 2 go into 12?
5.
A little bit more than that. 5 times 2 is 10. So 12 divided by 2?
5.
Nope, 2 6s. 2 6s are going to give me 12. So it's 2 times 16. Well, now we need 2 factors of 16. What's 16 divided by 2?
2 times something equals
2
16.
times what gives you 16?
8.
8. Very good. Thanks for the help, Adam. 2 times 8. We're almost there. 2 times what gives you 8?
4.
4. And how do you get 4?
2 times 2.
2 times 2. All right, so now I've got all this writing here, and I've got 1, 2, 3, 4, 5 2s. So I'm going to rewrite 64 as 5 2s. You may have seen this as a tree, a little prime factor tree.
Yeah, that's what they do
That's what we
sometimes
do.
in the elementary school.
Right. All right, so now we're going to circle anything that they have in common. All right, so I've got 1 pair of 2s here, a pair of 2s here, and a pair of 2s here. So when we multiply these 3 together, we're going to get our greatest common factor. So, Dami, can you tell me what 2 times 2 times 2 is? 2 times 2 is?
4.
And 4 times 2 is?
8.
8. So the greatest common factor of 24 and 64 is 8.
That's a lot of work
That is a lot.
for one little number.
Yep. And what I should have done is I should have set them up next to each other and done a little tree. But we get the same prime
Right.
factorization either way.
There's more
came
than
out-
one way to skin a cat, Miss Herring.
This is very true, Adam.
So you know what? Why don't we spin the wheel for Dami? What do you think?
Sounds like a plan.
Dami's a loyal dog.
Yeah, I think it's really good. Yeah.
Here we go, Dami. Get ready. So Ron's going to spin it.
So we'll see you guys next week.
Oh, the mystery prize! Do we have a mystery prize for you? I was just looking at this mystery prize today, and it is one spectacular mystery prize. Let me tell you.
What is it?
It's a
can't
mystery.
say.
Oh.
Dami, you can call us next week and tell us what your mystery prize is, okay?
But I'm going to be your guest spinner.
Oh, that's right. You can tell us in person. Isn't that fabulous?
That's
That's
awesome.
great.
Oh,
We
Dami,
won't
I
be
can't
here,
wait
though.
to see you in person next week.
Bye.
All right, see you guys.
Bye,
See ya.
Dami.
All right, now, why don't we go out to Edgemere Elementary School? Riley, a 4th grader out there, how are you?
Good.
So, Riley, you're going to be working with multiplications and maybe figuring out some products. Is that what I'm thinking?
Yes.
All right, what's your problem, and we'll work on it together. And you know
Okay.
what? Riley, can you turn your television set all the way down and just talk to us over the phone?
Can you say that again?
Can you turn your television set all the way down and just talk to us over the phone?
Mm-hmm.
That helps, because we get a weird echo. I hear myself.
I can hear you echoing.
Adam!
Adam. Multiplication.
Come! Products. Division.
All right, Riley, go ahead.
Let's
What's your
just do
problem
it.
today?
86 and 7/10 times 54 and 8/10.
Ooh,
54
we got
and
decimals.
8/10. Wow. Well, that's going to be a big product. Now, we don't have to line up the decimals in a multiplication problem, but we do. What I'm going to do is I'm going to bring up the calculator. And can you give me those numbers again? Well, let's move the calculator.
Slide it to the left, to the right.
86
Everybody move the calculator to the right.
7 times 54.8. And you know what's going to happen when I have the equal sign?
You're going to get the answer.
Look at the answer, and because there are two numbers to the right of the decimal points in each of the factors, you're going to have two numbers to the right of the decimal point in your product. So your actual answer is 4,751 and 16/100. So you would go ahead and just multiply that out. Do you know how to multiply that out? And you could check with a calculator after you multiplied. But it's important that you remember that you need to have two numbers to the right of your decimal point.
Miss Studi, would you say sometimes kids forget to do that the right way?
They do. Sometimes they just drop the decimal down.
No!
You do that and you do that.
No, tell me it's not true.
It's true. You can do that in
Don't
addition.
do that, kids, please.
If it were addition, it would be a different thing, but it is multiplication. So therefore, you want to make sure that you have two numbers to the right of the decimals.
All right.
Okay?
Well, I'm glad we solved that mystery.
I am too.
And you know what? After we solve a juicy mystery, I like to spin the prize wheel.
Yes, but then the mystery's not solved if they get the mystery prize.
That's true. We'll find out next week when Dami shows up. Kendra, wake up! Oh,
There she is. Oh, the robot.
The robot. Nice. Oh, another water bottle. And like I said, with the hot weather, you can never stay hydrated enough, especially when you're straining your brain, working on multiplication problems.
Yeah, people break a sweat doing decimal multiplication.
I know, as long as they
Thank
remember.
goodness for calculators.
Yeah, that's true. All right. Well, I'll tell you what. Why don't we move on to our next caller, okay? And this is a first-time caller.
That's awesome. We love new callers.
Gabriella, a 5th grader from Red House Run, and her name is Gabriella. Hey, Gabriella.
Yes.
How are you?
Good.
Oh, that is fantastic. I'm so glad you called today. This is the first time you called?
Yep.
Why did you decide to call today? I know you might need some help, but how did you hear about it?
They actually said it on the announcements.
Oh, I'm so glad you were listening to the announcements. I'm glad. I keep saying, when's Gabriella going to call? When's she going to call?
Well, now you've got your answer, Adam.
She may be the first caller from Red House Run.
Could be for a while.
We don't
that's
get
for sure.
many of
All right,
those.
so what's your problem? I think are we doing some addition too there, Gabrielle?
No, we're doing times.
Oh,
7 times
times.
56.
Little multiplication.
Say again?
7 times 56.
7 times 56.
times 7. And Adam, you want to remind Gabriella what we call the answer to a multiplication problem?
It rhymes with.
It doesn't.
What does it
Yeah,
rhyme
not
with?
a lot.
It rhymes with product.
If that's a word, and it is.
It is in puppet lore.
We have our puppet. It's a product. So, all right, Gabrielle, we're going to do some multiplication here. 7 times 6 is?
A product is the type of stitching in a puppet.
He's making this stuff up.
42. Very good. And then 7 times 5?
Cross stitch. A weave.
35.
35. And then we need to add the 4 to 35. And 35 plus 4 is?
39.
Very good. And there you have multiplied your two numbers. And your final answer, if you can see it on your TV screen, is 392.
Which rhymes with bollock. A special stitching in puppetry.
I don't think so.
What? You are. I am a puppet historian, you know.
I know, but that doesn't
You didn't
mean
even
you're
hear
a puppet
about the puppet
crafter.
rebellion. But you didn't even hear about the puppet rebellion of 1804.
I know, because I have laundry to do.
What does that have to do with anything?
It's time to spin the wheel.
You're avoiding the discussion.
I'm not avoiding the discussion,
All
Adam.
right, we'll spin the wheel.
I just want to get Gabriella her prize.
Okay, but you and I have to talk after the show.
Okay.
Oh, look at that. I like that. I like that move. Oh, another water bottle. These are just flying out the window today,
Yeah,
aren't
they
they?
are.
People must be
One
thirsty.
after the other.
I'm thirsty. I'm expelling such energy trying to educate you two on puppet history.
And making up words.
We'll get a book at the library and read all about it, won't we, Miss Herring?
We're going to go
All right, I'll
home
tell
and
you what.
Google buttock.
Why don't we go out to Newtown Elementary School? Titania, are you there?
Yes.
Hey, how are you?
Good.
Who's your math teacher over there?
Miss Barnett.
Oh, I love her. You know what? She's a great math teacher. You're lucky to have her. Yep. So what are you working on?
I'm working on geometry.
A what?
Geometry.
Geometry is my
geometry.
favorite.
Oh, yes. Miss Herring loves geometry.
What kind of geometry? What are we working on?
Yep, let's have the
If
problem.
they choose the word from the box that best completes each sentence, some words will not be used.
Okay, so you have a bunch of words, and let's go with the sentence first, and then maybe we can work on what the word is. Go ahead.
All right.
Okay. It says blank lines cross
me.
over each other and a certain point.
Blank lines
Cross over each other.
cross over each other
And at certain points.
at certain
This is not on the worksheet, is it?
No,
No.
Okay.
points. Okay, so the sentence that I have written up there, is that what yours looks like?
Blank lines.
Okay. What are our options for words?
Maybe you should shrink that so we can
Line,
Okay.
line segment,
Line segment,
ray,
Ray.
ray.
polygon,
Okay.
parallel,
Polygon.
Oh, that's the symbol for parallel. We probably don't have that yet. All right,
Here's the symbol.
parallel.
right angle,
I'm going to abbreviate right angle. Okay.
intersecting,
Intersecting.
perpendicular,
Okay, and I'm
Oh,
going to
you
use a
got
symbol there. Now, I'm going to stop right there, Tatiana, because I know that the answer is already in our list of words. But let's
Okay.
talk about this. We're talking about what happens when lines cross over each other at certain points. So if I drew two lines, they cross over here at one point.
Yeah, they sure do.
Okay, if I drew another line, it crosses this line, these two lines at 2 points.
Uh-huh.
Okay? So, it's not a line because a line isn't going to cross another line like that. It's not just one segment because we have more than one.
okay,
Did I make a shape with my lines?
Looks like a mess to me.
Yeah, it's a
No.
big mess, isn't it? So it's not a polygon, which is a shape. A ray has one endpoint and continues in one direction. Is that more than one line crossing over itself?
no,
Nope. Parallel lines don't ever touch each other. So could these lines be parallel?
no,
Okay.
Jose.
A right angle has to measure 90 degrees. Does this measure 90 degrees?
no,
Okay. Intersecting lines are lines that intersect. And intersect, if you think about when you're in the car and you go to an intersection, it's where one road crosses another road. Do you think these lines look like they could be roads crossing each other?
no,
Okay, well, they don't really look like roads because I drew them on the screen, but these lines, because they touch each other, are in fact intersecting. As soon as one line touches another line, it intersects that line.
And I think you like the way you said, like the intersection of a road because they're going to cross over each other, right?
Right.
And what's that last one again? That last
This
symbol?
upside down T is the symbol for perpendicular, and perpendicular lines are intersecting lines that intersect at right angles. So it would have used 2 of her vocabulary words to get perpendicular lines.
Ah.
Okay, if I drew perpendicular lines, okay, they would be 2 lines that intersect, and we would have to have a little box to show that they were a right angle.
Okay, well then let's just go with intersecting then.
They're just intersecting. Lines that cross each other at one point or more are intersecting lines.
All right. Wow, that was like an awesome geometry lesson all wrapped into one problem.
And
Well, thank
vocabulary,
you.
too.
Yeah, good math vocabulary. Nice work there, Miss Herring.
Thank you. It's
All
what I
right,
do.
you know what? Let's spin the wheel. What do you say? It's a Tanya one. Surprise. Oh, my goodness. I'm not sure what... Whoa!
Oh, what is
I'm
that?
not sure what that is.
Oh, my Lord. That was kind of scary.
It's like a real dummy was spinning the wheel. Oh, look at that!
What
Another
is that?
backpack.
A backpack.
You've got good eyes, Adam.
Yes, 20/20 vision.
Yeah.
All puppets have 20/20 vision.
They do.
They do,
Yes. As
even
long as
when they get old.
Yes, as long as they
Okay.
have eyes.
20/20 vision.
Well, they can just have 20 vision if they have one eye, like a cyclops.
Do they make puppet cyclops?
Oh, yeah.
Are there puppet
You
cyclops?
can dream it up. We're out there.
Okay.
All right, so why don't we
But
go
they were
out?
in the rebellion too.
Yes, well, we're talking about that after the show, right?
Yes.
Forget about the laundry.
Okay.
Syed, are you there? From Newtown, are you there?
Hello,
Syed, is this you?
this is Ziad.
Oh, Ziad, how
Ziad.
are you?
Good, how about you?
Good. Now, I'm doing pretty well today. What do you think of my nice hat?
I like it.
Thank you. Thank you very much. Now, who's your math teacher?
Miss Chess?
Oh, you know, we
Oh,
love
I
Miss
love
Chess
Miss
here,
Chess.
don't ya?
Yes.
She does a nice job. I mean, she does a great job on TV once in a while, you know, for an hour. I couldn't even imagine having the pleasure of her being my math teacher every day.
Well, ask Ziad.
Zia, that must be awesome.
Yeah, it is.
I'll tell her that. That's extra points for you. All right, so what's your problem today? We'll work on it together.
My problem is, which operational symbol is missing in the following? 9 blank 7 is greater than the 16. And there A is adding, B is subtracting, C is multiplication, and D is dividing.
All right, we're looking to see what operation will make this sentence will make this math sentence inequality correct. So if I put a plus sign and I say 9 plus 7, do you know what that equals?
16.
Can 16 be greater than 16?
No, it would be equal to.
Right, it would be equal to. So that's not going to help us. So we're going to cross that one out. Let's try minus. 9 minus 7 is
2.
2 greater than 16?
No.
We're going to
less
cross
than.
that one out. Let's go to C. 9 times 7. Do you know what 9 times 7 is?
73.
Well, let me show you a trick with the
Oh, yeah,
nines.
there's a trick, crazy trick.
There's lots of different tricks with the nines. If you do 9, let me show you on the side, 9 times 7, okay? If one of the factors is 9, the other factor is 7, you can take 1 less from 7. What's 7 minus 1?
8.
7 minus 1 is 6. And then 9 minus 6 is?
9, 6, 3.
3. And notice how your answer adds up to equal 9. 6 plus 3 equals 9. So we're going to say that 9 times 7 is 63. Is 63 greater than 16?
Yes.
Then we have completed the inequality, so that now it is true. 63 is greater than 16.
And you don't even have to worry about the division one because you
No,
know that's
'cause
not going to work.
Right, we already.
Yeah.
Okay, great
right.
job.
I used to
Very
know a
good.
hand trick for the nines.
Yeah, what is the hand
Oh,
trick?
yeah.
If you hold your hands in front of you
Right.
and you count, it's 9 times 7, so I'm going to count from the left. 1, 2, 3, 4, 5, 6, 7. What I have left that I'm looking at is 7 on this side of the finger that's down, 2 on this side. So it's 72. Now, if I'm doing it backwards to the people who can see it at home, I would count 1, 2, 3, 4, 5, 6. Let me put the pen down. 7. I put this finger down. There's 7 fingers here, 2 fingers here,
Yeah, I like that one.
72.
72.
That
And that
works.
works with all
Oh, yeah.
nines.
Yeah, do you remember that trick? That's a
do.
good one.
Yes, it is.
It's a good thing I have opposable thumbs, or I wouldn't be able to do that.
That's right.
You have to have all, yeah, never mind.
Yeah,
all right,
all your
let's
phalanges
spin
in
the
place.
prize wheel for Ziad.
All right, yeah, let's stop talking about fingers and spin the wheel. Okay, let us go. Oh, yeah. I like that. Oh, and look at that. A flashlight.
Flashlight.
Great. I love flashlights. You know, I like
Are you afraid of the dark?
No, I didn't say that. I said I love flashlights.
Okay.
You can only, you and I are going to have to talk it.
You keep telling me this.
I'm coming over to your house to help you with your laundry.
Well, hey, you can do all the laundry.
What?
You said you had opposable thumbs.
That's true.
All right, who's next, Adam?
Right. You know what? Why don't we go to Lansdowne Middle School?
Oh, okay.
I think this one's got Miss Herring written all over it here. I don't know,
I
but
do too.
Brandon, are you there?
Yes.
How you doing, Brandon?
Good.
Now, Brandon, you being an educated young man, I'm sure you've heard of the Puppet Rebellion of 1804, right?
No.
See?
He said
He
no.
said no.
Well, no means yes. It's a negative.
No,
Yes.
that's incorrect.
Yes means no.
It's not opposite day.
Oh, boy. What is it? What's your problem, Brandon? I can't win with these guys.
Well, my question is about angles, and since we just did a problem about lines, then this will be the next step.
Right up
Oh,
the alley.
great.
Go ahead.
Angle C and angle D are complementary. Find the measure of angle C if the measure of angle D is 75 degrees.
Okay. Angle C and angle B are complementary. We want to find the measure of angle C if the measure of angle B is 75.
Yes.
All right. Brandon, the first thing we need to know here is, what does the word complementary mean?
Yeah, what is complementary?
I think it adds up to 90 degrees.
Absolutely. Complementary is the sum of two or more angles that add up to 90 degrees. So we're going to say angle B is 75, and we're going to add angle C to that and get 90. Now, we can solve this like an algebraic equation, or we can just say if I need 90 degrees and I have 75, I can subtract. What is 90 minus 75? So over here on the side, we'll set it up so we can do the subtraction. 90 minus 75. Can I take 5 away from 0?
No.
Nope. So I'm going to borrow 1 from the 9. What's 10 minus 5?
5.
And then 8 minus 7?
1.
So 90 minus 75 is 15, which means the measure of angle C is 15 degrees.
Okay.
Okay? Do you know what you call two angles that add up to 180 degrees?
Is it supplementary?
Absolutely. Supplementary
Wait,
angles add up
I
to
thought
180.
complimentary was like, oh, Miss Herring, you have a lovely shirt on today. Oh, Miss Studi, I love your glasses. Oh,
Thank you.
Miss
That
Herring, I think
is
your hair looks great.
complementary with an I.
Oh.
This
With my
is
eye?
complementary with an E.
E?
And complimentary, where you're giving me a compliment, is complementary with a PLI.
Miss Herring.
Because you can see to give someone a compliment. I see.
That was
Get
the
it?
most wonderful explanation of complimentary I've ever heard. I must compliment you on your knowledge. I am stunned. I don't even know what to say. Let's just move on to the next caller.
Okay.
Nick from Seven Oaks.
Wait, we didn't
Wait, we
spin
gotta
the
spin
wheel.
the
yeah.
Wheel.
I'm sorry.
was
Look, he
it-
knows.
He is yelling at you, Adam.
I know. But I just was thrown off by that. I just never heard such a good explanation for complimentary before.
You know, I
Ah!
am known to shock people.
Hey, look at that! It's Sid. A magic math kit.
Oh, I have one of those right here. Magic math
Woo!
kit. Brandon, actually, since you're doing angles, this has a protractor and a compass in it that can help you
yeah, that
measure
would be
angles
perfect.
and construct angles. So that's good timing for
That's
that
good
prize.
timing. Well, thanks, Brandon, for giving us a buzz. Call us next week. All right, let us move on to Nick, who is at Seven Oaks. Nick, are you there?
Yeah.
Oh, Nick, how is everybody over at Seven Oaks?
Good.
Are there actually 7 oak trees over there? Did you ever count them?
No.
They're out in front of the school. Go out and look at them. They're 7. I planted actually one of them back in 1996 when the school opened.
Oh, okay.
If you believe that, I'll tell you another one. All right. Anyway, what is your problem? And we'll work on it together.
The least common denominator.
Okay.
That's the LCD.
That's the
the
LCD, as opposed to the
CF.
GCF, right?
Whew.
The greatest crazy friend.
Oh.
GCF.
No. Greatest common factor.
Well, I'm working on 9 and 6.
The greatest common the least common denominator of 9 and 6.
The LCM.
The LCM or the LCD are the same thing. It's an LCD if we're working with a what do you call it? Fraction. That's the word. Now, do you know what to do? How to go about starting to do this?
Yeah.
Okay.
We're starting to do this.
What I would suggest, because these numbers aren't too big, is to start counting by 9s and counting by 6s until you come to a number that is the same and is the smallest number. So let's count by 9s. 9 times 1 is 9. 9 times 2 is?
It's 18. I mean 16.
No,
I was right. 18.
You're right. 9 times 3?
27.
Okay, and 9 times 4?
How far do you usually go, Miss Studi?
I go 4 or 5.
Okay, makes sense.
9 times 4?
36.
Okay, let's go jump down, and now let's skip count by 6s. 6 times 2 is?
12.
And 6 times 3 is?
18.
Up. There's an 18 up here and an 18 down here.
Well, rubber band those.
We're going to rubber band these because that is your least common denominator or your least common multiple. That's the smallest number that is a multiple of both of these numbers.
Okay.
Okay?
That worked out pretty well.
Yeah. Sometimes it always doesn't work quite as well.
Sometimes you might have to do a lot of numbers, huh?
Yeah.
In worst case scenario, you can just multiply the two numbers together.
True.
Wow.
And I found
That is crazy. Miss Herring, you are a wealth of knowledge in so many different categories, I don't even know where to start.
I found a trick that if you find the GCF of these, which is 3, and then divide 9 divided by 3
Yeah.
is
3.
And then you multiply it by the other number. There's your LCM.
4.
So you find the GCF of the two numbers, 9 and 6. You take one of those numbers and divide it by the GCF, and then you take the quotient and multiply it by. Isn't that neat?
That's a lot to remember.
I
just
could
like
listen
listing
to
them.
you guys all day talk about math. You know that?
No, I just learned this after 28 years of teaching.
You never stop learning. Who says you can't teach an old dog a new trick, right?
Are you calling me a dog, Al?
No, it's just a metaphor. I didn't mean it to be mean. It's complimentary.
You know, George Washington said never to say a lie.
It's complimentary.
Oh, thank you. With an I?
No, with an E. All right, let's spin the wheel. Please.
Let's see the wheel spin.
All right. Come on. Oh, it's Kid. Come on, Kid, spin the wheel.
Kid and Sid?
Yeah, they're from Kid Conversation. Oh, flash drive.
Wow.
That's like
Nice.
a 2 gig flash drive, too.
That's a lot of memory.
I could use a little of that memory.
I could too.
So could the teleprompter operator. Anywho, let's go out to Padonia International and talk to Amira. Are you there?
Yes.
Hey, Amira, how are you?
What did you say?
I said, how are you?
Good.
How do you like my hat?
I love it.
I would tip it to you, but I can't get it off my head. It's stuck.
It's going to make it tough to go to sleep tonight, Adam.
I know. Anywho, I think my brain has swelled into the hat itself. Can you take it off? Ow! That hurts.
It's too painful.
I know it's painful. Sorry.
We'll just leave it on.
Leave it on there. All right, what's your word problem, Amira?
Sorry, Adam.
We'll listen carefully while you say your word problem.
It says, which transformation shows figures that are not congruent?
That's going to be kind of hard to do.
Yeah, we're going to have to see those pictures.
Yeah, I wonder, is there any way to describe
Now,
that?
I can tell you this, Amira. If you have a transformation, I'm going to do a little house, okay? Let's say you have a figure that looks like this, all right? And if you have one where the house is a little smaller, these two are not congruent because one is smaller than the other, okay? But if you have something like the letter M and you see it, M's not going to work, is it, Stacy? If you have something
Did you just
like...
talk to yourself?
Yep. I did just talk to myself.
In the third person?
In the third person. If you have something like the letter C,
Adam liked
and
that.
then you see it look backwards, that's a reflection, but
Adam
it
thought that
doesn't
was
change
funny.
its size, so those two would still be congruent. If you also have that letter C and it's just moved somewhere, that would be a translation, and those two are still congruent. The only transformations that change size, so they're not isometry, so the two figures are not congruent at the end, is the dilation, where one becomes bigger or smaller than the other. Is one of those an option for you? Not necessarily my pictures, but do you have a picture where one figure is smaller than the other?
Uh-huh.
Okay, well, that's the one where they are not congruent. If one is smaller than the other, they're not congruent, because congruent means same size, same shape. Okay? So they have to be the same size in order for them to remain congruent.
Wow.
You're learning a lot.
And that's called a dilation.
I never heard of that word before.
Really? What do you guys call them?
We call them translations.
A translation is a slide, a rotation is a turn, a reflection is a flip. If you make one bigger or smaller, it's a dilation.
I didn't know that. That's interesting.
Boy, I once again, I just love listening to you two.
Thank you, Adam. We love listening to you, too.
So, Amira, I'm glad, even though we couldn't see your picture, that I was able to help you.
Yeah, so why don't we spin the wheel for Amira and win her a prize?
All right.
Come on! We got a coal miner over there.
Thank you.
Thanks for calling, Amira. Let's get your prize.
She's measuring the wheel, the diameter of the wheel.
Right, the diameter. Oh, another flashlight!
Woohoo!
Right.
That'll brighten things up at Amira's house. She could do her homework in her room.
If she shines it in her eyes, she will dilate her pupils.
Oh, look at you. You're still going, aren't you? Look at you.
Dilation, I get it.
See?
Boy, oh boy.
That's how I
nice.
explain
I
it to
have
my
heard
students.
dilation before.
Uh-huh.
Yes, your eyes go big.
You know what? Why don't we go out to Bedford Elementary School? Solomon, are you there?
Yes.
Hey, how are you, Solomon?
Good.
Good. So you're working on fractions. Is that true?
Yes.
All right. Why don't you give us what you'd like to work on, and we'll work on it together.
How do I make one tenth into a mixed number?
How do you make 1/10?
Into an improper number.
1/10 into an improper.
Okay, well, one.
1/10.
Do you know what an improper fraction is, Solomon?
Yes.
Can you tell me what that is?
It's
What?
no.
Solomon's voice suddenly got really deep.
Yeah,
I think someone else is helping Solomon at home, too.
Well, Solomon, an improper fraction is a fraction where the numerator is larger than the denominator. For instance, I could say maybe 8/3.
Okay.
So the numerator is 8 and the denominator is 3. And if you want to make it into a mixed number, what you have to do is you have to divide the denominator into the numerator. So we'll divide 8. 3 goes into 8 around 2 times. Then you subtract. And then the answer is less than the dividend. So the 2 is going to be your new numerator, and the 3 will be your denominator. So 8/3 written as a mixed number is 2 2/3.
So he said something about 1/10.
Yeah, now you said 1/10. That wouldn't be an improper.
1/10.
What's that?
Yeah, 1 and 1/10.
Oh, 1 and 1/10.
1 and 1/10.
Oh, I'm sorry. I didn't hear you.
Okay.
All right, let me start over. 1 and 1/10. And you want to make that into an improper fraction, correct?
Yes.
There
All right.
we go.
Now I gotcha. You take the whole number, which is 1, and a mixed number is a number that has a whole number and a fraction. So 1 is our whole number, and 1/10 is our fraction. And the first thing you have to do is take the whole number and multiply it by the denominator, which is 1 times 10 is. Do you know what that is, Solomon? 1 times 10?
10.
Great. And then you're going to take the numerator and add it to the 10. So 10 plus 1 is 11. So 1 and 1/10 written as an improper fraction would be 11/10. And it's improper because the numerator is larger than the denominator. And then you can go backwards. So you can go from a mixed number to an improper fraction, or from an improper fraction back to a mixed number. Does that help you?
It helps me.
Yeah? We haven't had one of those in a while.
I know. You know, fractions are one of those things that
They're kind of
are fun
fascinating.
if you just...
Fractions are your friends.
Fractions are your friends.
That's what I tell my students.
Do they
No, they always want to type it in a calculator and give me a decimal.
Oh, okay.
Decimals are for the devil.
tell you what,
Fractions
though.
are your friends.
What? Really?
That's what I tell them.
Oh, okay. Why don't we spin the wheel?
Okay.
And we'll do it properly as opposed to improperly.
58.
All right. Let's spin the wheel. Here we go. Oh, yeah. Woo-hoo! Oh, some sunglasses.
All right, for all that sun that's coming out, because
Yeah,
we're not
really, it's a
getting
sunny
any
day.
snow.
We'll send those
That's the truth.
sunglasses right out to you.
The only snow we're going to see is right here on the screen.
I know, that's probably the only snow we're going to see this year, it looks like, isn't it?
No, it's going to snow Sunday night when we're already off on Monday. No snow days.
Really?
Of course.
That's what
So
they're
now
saying.
you're a weather girl.
I just listen to Tony Pan in the morning.
But then we can get out to school early.
All right.
We're
All
not
right, you know
in
what?
school on Monday.
Let's go
'cause
out to
it's
Deer Park
President's
Middle.
Day.
What do you say?
I'm ready.
Soraya, are you there?
We're gonna keep doing that.
Soraya? Hello?
I hear her.
Hello?
Hi,
Soraya, are you there?
Zaraya.
How are you?
Good.
So, what are you working on over at Deer Park?
We're multiplying fractions.
Okay, we were just
I mean,
doing
not
some
multiplying decimals.
You're multiplying decimals?
Well, Miss Studi's an expert at these today.
Oh, we just talked about multiplying
Oh,
decimals, didn't we?
Miss Herring's going to let me do another one.
All right, what's your problem there? And then we'll work on it together, and we'll see if we get make sure we do it right.
45 and 5/10 times 5 and 5/10.
5 and 5/10.
Okay, so
All right.
there's the decimals.
So let's start with let's forget about the decimals for right now, and let's multiply.
Forget about them.
Just for now, Adam. We'll come back.
All right, all right.
455 times 5. So what's 5 times 5?
25.
Okay, we're going to put the 5 and regroup the 2. 5 times 5 is 25 plus 2 is
27.
good. Carry the 2. 5 times 4 is
20.
plus 2 is
22.
good. Now what do we need to do?
Add your 0 at the bottom in the 10th place.
Correct. We're going to put a 0 to hold the tens, to hold the ones place, and then we're going to just multiply 455 by 5 again, but we already know what that is. So 5 times 5 is 25, 27, carry the 2, 5 times 4 is 20, so 22. Now what should we do with these two numbers that we're finding the product of?
You add them together and then you put your decimal point down.
All right, let's add them together.
Add them up. Did you
Five.
say? You call
Add 'em
my
up.
name?
Adam, here's his name. What's 7 plus 5?
12.
Good. Let's regroup. 1 plus 3. I'm sorry, 1 plus 2 is 3, plus 7 is 10. Carry the 1. What's 1 plus 2?
3.
Plus 2.
5.
Good. And then we're just going to bring down the 2. Now comes the tricky part. Now we want to make sure that we have the amount of spaces that we need in our product. So if you look up at the factors, 45, there's one number to the right of the decimal here, and there's another number to the right of the decimal in the second factor. So we know that there are two numbers to the right of the decimal. So we have to have two numbers to the right of the decimal in our product. So we're going to start from the end of the number and go to the left. We're going to go 1, 2. And we're going to put the decimal there. There's two there. Now there are two numbers to the right of the decimal. Can you read what our product is?
250 and 2500.
Perfect.
Woo!
Wonderful job.
That was read perfectly well.
Thank you.
It was
And we're
very
going
nice.
to spin the wheel for you because of that wonderful work. Kendra is going to do the honors. Come on, Kendra. Spin us something. Oh, yeah. Oh, yeah.
Oops, she's got
There
her
we
mojo
go.
going.
Oh, another water
Water
bottle.
bottle.
Well, that's like the fourth one today, isn't it?
I think it's going to be hot.
I know. We're getting ready for the warm weather. All right, you know what? I think we have enough time for Samuel, a fifth grader who is also at Newtown. Samuel, are you there?
Yeah.
Okay, what are you working on today, Samuel?
I'm working on 22 plus 18, and which one fits? Is it greater than sign, less than sign, equal sign, or times sign? And the other number on the right side is 351 divided by 9.
22 plus 18, and is it greater than, less than, equal to, or times 351 divided by 9? All right, so Samuel, we're going to do this pretty quickly because we're almost out of time, but 22 plus 18, first thing we need to do is simplify both sides. So 22 plus 18 is 50. No, just kidding, it's 40. See what happens when you try to rush, Miss Studi?
I do.
8 and 2 is 10, carry a 1, 2, 3, 4. So that's 40. And 351 divided by 9. All right, Samuel, 9 doesn't go into 3. It goes into 35 2 times. That's 27. When I subtract, I'm left with 8, and that's 81. 9 goes into 81 9 times. So this is 29. So is 40 greater than, less than, equal, or equal to 29?
Greater than.
Oh, 9 does go, it is 3 times. I wrote 27, but I put a 2 up there
You're
instead of a
rushing.
3.
That's what we're rushing, I know.
See what happens? This is why I tell my kids not to
Yeah.
rush, take their time.
All right, fix the 29
I'm going to
up
fix
above.
it. This is 39. See, I got all rushing. This is what happens. All right, so now we're going to try this one more time, Samuel. 40 and 39. What sign is going to go between them? Greater than, less than, equal to?
Greater than.
40 is greater than 39. Absolutely.
Okay.
You know what's funny about this one, Miss Studi? We did this one before the show started.
We
Gotta
did.
go. Yes, we do.
We need a snow day. We're
Uh-oh.
getting tired.
Well, guess what?
What?
We're out of time.
Oh, first we have to
we gotta
spin the
spin the
wheel.
wheel.
for
I know,
Samuel.
that's why we got to spin the wheel.
Oh, okay.
They're ready.
We'll get it
They're
in.
ready
We'll
for
get it
ya.
in.
And
The last bit of the day.
Oh, come on now. Yeah. A desk stuffer.
stuffer.
All right, we will send that right out.
all right. I
Ugh,
think
now.
we've given away every prize that's on that
Yes, we
wheel
have.
today.
Well, guys, time's up for today.
Oh, no. Can you believe it?
I can't. It went really quickly.
Well, that's because we rushed at the end. Congratulations to all our prize wheel winners.
Yeah.
And thanks to our spinners.
Yes, our studio spinners, our camera people did a wonderful job, didn't they?
Yes, they
And
did
you know,
great.
remember, kids, we do like to re-air this episode of Math Homework Helpers throughout the week, so sure to tell everybody to watch. There you go. And from all of us at Math Homework Helpers, we'll see you next week.
Only here on BCPS-TV.
And we'll see you now.
Comcast
Let's-
73.
Let's talk
and
about the public
Verizon
rebellion of
34.
1803.
No, but I gotta go do laundry. I'm
No,
gonna
no,
hurry up
stay
and
here,
run
stay
out of
here.
here. No,
We
I
gotta
gotta
talk
go.
about the
Out of my.
No,